Hi everyone, in this video tutorial we will try to understand what are volumes in containers and why we need it in the first place. So we will understand why we need volumes. We will first understand what is the need of volumes, what issue volumes really solves, and then we'll move forward in a practical way. Okay, so if you've watched my other videos, you must have noticed that I like a way to understand different stuff by doing a hands-on example. Okay, so in this one also we will basically understand volumes in container using hands-on example. Okay, so first of all we will start with Docker volumes. Okay, so we'll understand from the basic part, okay, how volumes are created in Docker, and then we'll move forward into Kubernetes part. Okay, in Kubernetes part we'll understand how volumes are created using different resources like storage class, persistent volume claim, and all those stuff. So we'll understand that in the Kubernetes part. So this is going to be a long video, so for your help, for a easy access, I will provide chapters. Okay, so you can basically refer to the chapter you really like to go through. Okay, but I would recommend you go through the video from start to finish, so you will get the overall view of why we need volumes and what how can we create volumes in a container world. Okay, so to make it practical, we will be using a MongoDB container, basically a database to basically store our data onto the MongoDB database. So we'll be using a database to basically store our data, and that data will be persisted even the container is restarted or terminated. Okay, so we'll see that how we can implement volumes. So this is going to be a really fun tutorial, and we will learn a lot of things in how we can create deployment services, PVC, PV, and all those stuff. So it's totally loaded. So without wasting any further time, let's get to the video. Okay, so let's begin understanding volume on a higher note. So we'll basically understand the storage and volumes and how it really happens and why we need it in containers. Okay, so generally when we deploy our containers, they don't have any storage by default. Okay, so they basically don't persist anything. So whenever your container is terminated or deleted or something like that, your storage or your data is going to be deleted as well. So generally this is the default behavior when creating a container. Okay, so basically containers are ephemeral. This is just a fancy word saying that containers are short-lived and they don't persist data in any form by default. Okay, so basically we need a way to add storage to it so our data is maintained throughout its life cycle of the container, so it does not get affected, the data or the storage does not get affected even if the container is restarted or deleted in some sort of way. Okay, so in this, to overcome this scenario where volumes come. Okay, now in this tutorial we will understand volumes in Docker. Okay, then we will understand volumes and how we basically handle volumes and storage in Kubernetes as well. Okay, and how we can retain data if the container is terminated or destroyed. So we will understand basic storage in both Docker, and then we'll move to containers orchestration, that is Kubernetes. Okay, so now let's cover the technical aspect of this video. Now the architecture part and the text part. So basically the basic architecture should be like the storage part and the container part, but I've added a little flavor in it to understand it a little bit more easily. So what I did is basically created a simple React application. So using this application, a user can create a to-do and basically list the to-do. So we will have two basic functionality, that is to create and to list. Okay, now this React application will be used along with a Node.js application. So basically it will use this data, the to-do data, and it will basically persist that in a container running a MongoDB database. Okay, so MongoDB will basically save your to-do list and will basically create the to-do list, and that will be saved on the MongoDB server. Now the good thing is that we don't need to install MongoDB. We will be using containers to handle that. Okay, now we'll basically, as I told you, we'll have a storage. Basically to-do list will be stored on this MongoDB container running locally on your system. Okay, so this is the front end application we'll be using to see our to-do list. Okay, now as you can see, I have multiple to-do lists already added. So currently I have 3. I can add one more here. Okay, and it will let me open the network tab and show you that it is currently interacting with the backend that is running currently on my local system. Okay, if I add a to do, it will basically add a to do to the current MongoDB container running locally on my system. Okay, and it will fetch to do from the MongoDB container. Okay, so if I refresh it, it will basically get all the files from the MongoDB container. Okay, now let's go and see a little bit of code part and how we basically do this. If you come up in the code part, you can see multiple folders here. So fe, mongo, server, and a Docker file. Okay, so for the sake of this video, I will recommend you to ignore front end and server part. Okay, because we are not going to dive deep in front end as well as the backend stuff. Okay, this Mongo folder basically consists of the manifest file, Kubernetes manifest file, that we will look on in the later stages of the video when we will be working with Kubernetes volumes. So I have already created the container and the images for MongoDB running locally on my system. So this Docker file is used to do that. So this is a simple Docker file. So let me give you a little bit of overview of it. Basically, I'm getting the MongoDB latest image and I'm creating this directory here, which is basically used for MongoDB to save persist data, and this directory will be created inside the container. Same, I'm adding a volume up here, and this is the command which will be going to run after the container launches. Okay, now I have already created this container and this container is really working. That's why we are able to see the result here. Now, so I will be using another tool, that is MongoDB Compass. So it will help us to visualize all the data in our MongoDB database, like the collections and database and all those stuff. It will be easier us to visualize all those data. So let me pull that onto the screen. Okay, so this is the MongoDB Compass. So as you can see, we have that database here, todo_db, and this is todo, this is the collection which contains all the to-do list. Now this database is basically inside the container which is currently running. Okay, so if we do docker ps here, you can see this container running with this image MongoDB with volume. Okay, inside that container we are having all this list here. Now what I will do is basically going to delete this container and see if the data persists or not. Okay, so to delete the container, we will use docker rm command, and I will get the container ID and press enter. As you can see, it's deleted now. As soon as I delete it, if I go back to our front end and I refresh the page, you can see it's not loading up the to-dos. Okay, now what I will do is basically going to run the container again. For handy purposes, I have already added some commands up here, so we'll be using that command. Okay, this command is to basically run the container, okay, on the same port that is currently on my machine and the port running inside the container. Okay, so let me copy this and run this again. So as you can see, the container is up and running. Now if we go and refresh, you can see the server is working fine, the MongoDB connection is working fine, but I don't have any to-dos. So if I add something here, it will get added, but when I again delete the container, it will be deleted. Okay, now let's see how we can persist this using a single command that Docker provides us to basically add volumes to this container. Okay, to do that, first I will basically delete this new container. So it's deleted now. Now to add a volume to a Docker container, we have another command, which is this one. Okay, so this command is quite similar to the first command to basically run the container, but we are attaching a volume to it. So this v flag basically attach the volume to this container. Now this volume flag have two attributes assigned to it. So the left side one is location of the directory where MongoDB will be saving our data. So this one will be on our local system, and this is the one that is in the container. Okay, so let me add this volume. So I will copy this, and inside the terminal I'll just gonna run this command. So as you can see, our container is up and running. Now if I go back to our front end and refresh the page, you can see the status is 200. Now let's add some to do here. So like okay, so we have added 3 to-dos in our to-dos list. Let us refresh and see if the data is persisted. So it is coming from database. Now let's go back to MongoDB Compass, connect, and as you can see we are having our to-do DB here. So if I open this and go to to-dos, you can see our to-do list is available here. Now again what we'll do is going to remove this container, and it's deleted now. Okay, now again we'll create the container using the same command and see if the data is persisted or not. Okay, so we have created the container again, and let's go back to the front end, and if you refresh you can see we are getting the data back again. Okay, so this is coming from the database that is running on your container, which is syncing data on your local machine as well in your Docker container. Okay, so this is how volumes really work inside Docker. Okay, move a little bit on the advanced side and see how we basically use volumes in Kubernetes as well. So let's get to the Kubernetes part. Okay, let's understand volumes in Kubernetes. Okay, so let's begin by understanding how different resources are created for achieving the persistence in a Kubernetes cluster. Okay, so let's start with the overall architecture. So we have our cluster at the top. Okay, now inside the cluster we probably have some node running. This can be multiple. Then we have our deployment. Okay, so this deployment is currently with MongoDB. Okay, so the first thing is a storage class. Okay, basically we write storage class to like provision different storage class onto a Kubernetes cluster, and this is a cluster wide source. Okay, so any other different node can also use this. Okay, then we basically assign PV, which is known as persistent volume. Okay, then we basically assign the next thing is a persistent volume. Okay, so now this persistent volume is basically node specific. Okay, so a single node can have multiple PVC, but that will be existing on the current node only, and that PVC can be accessed by our pod running, that is the MongoDB server in our case. So this is the overall architecture we'll be working on, and we will see how we can create storage class, persistent volume, PVC, and all those stuff to basically access MongoDB Docker chapter. We basically understand how we can use volumes in Docker using command line. Okay, Kubernetes we will use a declarative approach. Now we will use manifest file to create resources in Kubernetes. Okay, so in the folder structure you can find Mongo, and inside that we have multiple YAML manifest file. To create resources we need to create YAML files in which we write the steps, and that steps is read by Kubernetes cluster, and it basically create all those resources on our behalf. So let's get started by understanding different resources we'll be creating for this application. Now if you remember the slide, use the same hierarchy. Okay, so we will be creating the first resource, which is a storage class. Now storage class is basically a resource which if you don't create, it will be basically used the default provisioner. Okay, now let's understand what storage class is. Okay, so a storage class in Kubernetes defines the type and properties of storage that an application can request. Okay, now as I showed you, this is basically a cluster wide resource. Okay, so in a storage class you can specify the storage, what kind of storage would you like if you want SSD storage or a slower storage like an HDDs. Okay, and or if you want some data backups as well. Okay, now the main use of storage class is basically to handle different storage resources, how they are allocated and managed within the cluster. Okay, so this is the main use of a storage class. Okay, now there can be multiple storage classes, but for the sake of easy understanding we will having a single storage class in our example. Okay, now let's break down this file a little bit and understand what it is of. Okay, so if you worked with Kubernetes, you must be knowing all this key. Okay, so this API version, kind, metadata and all those stuff. Okay, so in the API version, in basically we define specify the Kubernetes API version used for this particular resource. Okay, so in our case we are using storage class, so storage class comes under storage.kx.io in the volume 1 API version. Okay, so and the kind is of course storage class. Okay, then we have metadata. So in the metadata we have name, which specifies the name of the storage class. So this name is used to uniquely identify the storage class within the Kubernetes cluster. Okay, next we have provisioners. Okay, so it basically indicates the provisioner responsive for dynamically provisioning storage volumes. Okay, currently in our example we are using kubernetes.io no provisioner. So this provisioner indicates that no dynamic provisioning is available for the storage class. Okay, it is typically used when you want to manually manage the storage resources. Okay, so currently we are having on local system, so this for development purpose it will work fine. Okay, I will show you the other ways that we can use provisioners as well. Okay, the next thing is volume binding mode. Okay, so it basically defines the binding should occur for the PVCs or the persistent volume claim we'll be creating in the later stage of the video, that basically reference this storage class. Okay, and it basically have multiple options. So one of them is wait for customer. So what does wait for customer does is basically the volume binding is delayed until the first pod using the PVC is created. Okay, so this mode is suitable for when you want to bind a specific pre-provisioned volume only when there's a consumer or pod is ready to use it. Okay, so basically it provides more control over volume allocation and ensures resources are utilized efficiently. Okay, so this is the use of volume binding mode. So this is storage class. Okay, so we need to create storage class. Now if you want to learn more about storage class, you can simply go to kubernetes.io in the Kubernetes official documentation, and you can find different options that are mentioned here. Okay, so as we use this one like provisioner, reclaim policy, and volume binding mode and all those stuff. Now for example, if you want to deploy your application on a Kubernetes cluster, on an AWS cluster, that is the EKS, you can basically search for AWS, and you can see we have an option here that is AWS EBS. So it is AWS service of block storage that basically provides you with the volume integration on AWS. Okay, so as you can see we have a simple example that you can use, but we are not using AWS EBS, maybe for some later on videos, but we are basically using the local storage for this, so we're not gonna dive deep inside the EBS part. But now if you want to work with volumes on AWS EKS or something like that, you would probably be using EBS for that case. Okay, now this is done. Okay, so this one is done, so storage class is done. Now the next thing we'll be creating is basically the PV. Okay, now the PV is also a cluster wide resource that can be used within the cluster only. So the normal uses of, let me open the PV file first, so this one. Okay, now let's understand what PV is. So a persistent volume or PV is a piece of storage in the cluster that has been provisioned by an admin or dynamically provisioned using a storage class. Okay, so it is a resource in the cluster just like a node in a cluster resource. Okay, so it can be a physical disk, a network storage volume, or any storage resource supported by Kubernetes. Okay, now it has the life cycle of independent mode, like for example, if any individual pod that uses the PV, if the pod is deleted, the PV will not be deleted. Okay, unless it gets deleted by any end user or any admin. Now again, if you want to read more about PVs, you can again go to the Amazon documentation, Kubernetes documentation, and you can search for PV. Okay, this one, and you can basically get the different options which you can add. Okay, now again, if you want to add some AWS functionality, you can basically need to search for AWS, and you can see it provides us with how to integrate with AWS. Like we as I told you, we will be using EBS if you're working with AWS, that is the elastic block storage. Now in our current tutorial, we are using host path because we are using the persistence on our local system, which basically we are using our system storage only. Okay, so this is persistent volume. Okay, now let me go down and explain you some of the nitty-gritty details of this file. Okay, till here you may be understanding everything. So this is the version, and inside that we have the kind persistent volume. Then we have the metadata, which basically the name of the PV. Then we have the spec block, which is the most important one. Okay, so we'll be focusing more about on the spec part. Okay, so let's understand the spec part. Okay, so the first one is capacity. So this one, so it basically specifies the capacity of the volume. Okay, so here we are assigning 1 GI, which is basically 1 gigabyte, but you can adjust the size as you need for your application. Okay, then we have volume mode. Currently I'm using file system because, as I told you, we will be storing our data in the current system file storage. Okay, other type it can be block or something like that. Okay, but we'll be using file system for this one. Then we have access mode. As I told you earlier, we have multiple access mode. Currently we are using read write once. Okay, so read write once basically means that this PV access can be accessed by a single node. Okay, this means that the volume can be mounted as read write by only one node in the Kubernetes cluster at a time. So as I told you, as I showed you in the slide, is a cluster based resource. Basically it can be accessed anywhere inside a Kubernetes cluster. Okay, then we have the storage class name. Inside that we pass the storage class name, which is we defined up here. Okay, if we don't have any storage class defined, it will basically pick the default one, which is dynamically provisioned by Kubernetes for you. Okay, then we have persistent volume claim policy. Okay, so it basically says what will happen if the persistent volume is released. Okay, now so if we are passing it retain here, so it basically means that the volume and any data on it, even after it is not used by any pod or something like that, the data will stay available. The persistent volume will stay available. Okay, until or unless or any admin basically deletes it. Okay, so this is what persistent volume claim is. Okay, then we have host path, and inside that host path, as I showed you, we are using the current directory on our local system. So we are using this path, so where the database MongoDB data will be stored. Okay, now if you want to learn again more about host path, we can basically go to persistent volume again. Okay, and here we can search for host path, and you can see we are having the host path here. And if you want to add something like AWS, okay, then we need to search for AWS, and inside that we can get how we can add AWS storage persistent volume inside our cluster. So this one is also done. So according to the slide, we must move on to the next one, which is the PVC. Okay, so let me open PVC. Now, as I showed you, according to the slide, PVC is basically accessed by a individual pod. Okay, so PVC or persistent volume claim in Kubernetes is a request for storage by a particular pod. It allows you to use storage resource in a cluster without having to configure specific details about the underlying storage. Okay, so it basically means PVC abstract away the implementation details of storage, such as whether the storage is provided by local disk network storage or cloud storage. It abstract those details from the pod. Okay, so we basically define those in PV or in storage class. Okay, basically the use of PVC is like dynamically provisioning. Okay, so when a pod requires storage, it creates a PVC which requires a certain amount of storage capacity and different access mode, and onto which it can access the different data store or databases. Okay, now in our example we are working with MongoDB. So okay, so we need to define a PVC that requests a specific amount of storage from the cluster. Then the PVC can dynamically provision a persistent volume that meets the requirement specified in the storage class. As you remember, we also added that 1 gigs of the storage will be available to be accessed by any pod using this PV. Okay, so now let's tear down this file as well a little bit. So API version and the kind is self-explanatory, so I'm not going to dive deep into that. Also the name, so we are providing MongoDB PVC. Okay, then in the spec we have access mode. As I told you earlier, there are different access mode. So currently we are using read write once. Okay, so read write once basically means the volume can be mounted as read write by a single node in the cluster at a time. Okay, other mode include read only many, which can be read by many modes, and read write many, which can be read write by many modes. Okay, then we have resource, and inside resource we have request. Okay, so here we are passing 1 gigs. So this is the amount which this pod or the MongoDB pod will require to store data onto. Okay, so it basically indicates the amount of storage requested by the PVC. Okay, so this size should match or be less than the capacity that is provided in the PV. So we are currently using 1 gigs here, but it should be less than the what we provided in the PV configuration. Okay, so this is the 3 main resources that you need to create to basically store your data, persist your data onto a Kubernetes cluster. Okay, now apart from this, we need a deployment. Okay, so this deployment is basically a simple deployment where we are launching one replica and using the MongoDB latest image, where we are assigning the port, and inside the volume mounts we are basically using the default storage directory inside the container. Okay, where MongoDB stores the data, and inside the volumes we are using the PersistentVolumeClaim. Now let's see how this really works. So here we have mentioned that the PersistentVolumeClaim name is MongoDB PVC, so it will go up here. It will see what is the configuration written and how much storage is available. So now this PVC will access the PV, and it will see what is the configuration here, that what kind of storage class is required, what is the access mode, the capacity, and the host part where we basically want to store this data. And then this PV will access storage class to basically see the provisioners and all those stuff, like where we want to store like the fast SSD or some simpler slower SSDs. Okay, so this is the overall hierarchy. Okay, apart from that, we have a service. Okay, so I have created this service file to basically access MongoDB onto our MongoDB and see how the data is really stored. Okay, so again we'll be using that application which we used earlier, that is MongoDB Compass. Okay, so all this is ready. So now let me open the terminal. Okay, and I'm inside the Mongo folder, Mongo directory. Now here we need to create the resources. So to create the resources, we will use kubectl again, kubectl apply -f period, which basically means we are applying all the configuration present in the current directory. Okay, so let me press the enter button, and as you can see, we have multiple resources created. The first one is the deployment is created, persistent volume is created, volume claim is created, service is created, and the storage class is unchained because I have created it earlier. Okay, let me open the Node.js server and see if it's running. Okay, so as you can see, my backend server is not able to connect to the MongoDB server. So to do that, to access MongoDB server, so we need to port forward the MongoDB service running currently on the cluster. Okay, so let me see the services. Okay, so as you can see, the MongoDB service is currently running as a load balancer on my local system. Okay, so if you're having external IP, or you deployed this service onto some AWS or something like that, you will be basically getting external IP which you can access, but we are working locally, so we need to port forward it. So to port forward it, we will use kubectl port forward service MongoDB and the port inside the cluster, inside the pod, and the port in our current system. Okay, so let me press enter, and as you can see, the port forwarding has been started. Now let me open MongoDB Compass and let me connect to the local host. So we are connecting to a MongoDB pod running inside the cluster. Okay, so let's connect. So as you can see, we don't have any database currently configured here. So what we're going to do is to basically restart our Node.js server. So as you can see, the MongoDB is connected now, and if you open MongoDB Compass here, and if I try to refresh, you can see the collection is created. Okay, currently it does not have any to do, so we will basically use our front end to add the to do. Okay, so let me open my front end again. So let me add some to dos here. Now let me go back to MongoDB Compass and basically refresh it here, and you can see we are having our to dos up here and it is listed. Okay, now let me delete this pod and see how if the data storage is available or not. Okay, so to basically view the overall cluster in our local machine, I'm using another tool here. If you want to install, you can just go ahead and Google K9 and you will basically get the tool. So this is a very good tool you can use to monitor your Kubernetes cluster. Okay, so as you can see, so currently I am showing the service, so you can see the service is MongoDB is currently running. Now if you go to see the storage class, you can see the MongoDB storage class is available here, and the provisioner is the Kubernetes IO, which is the local one. Okay, if you have something like EBS and all those stuff, it will be mentioned up here, and you can see the binding mode, which is currently for wait for first customer. Okay, now let's see PV, and you can see we are having the MongoDB PV, which with the capacity we mentioned, that is 1 gigs, and the reclaim policy is retained. Also the access mode is also mentioned here, read write only, and the status is it is still available. Okay, now let me go to see PVC, and you can see in the PVC we have the MongoDB PVC, and it is currently bounded to this volume. Okay, and it basically have this much of capacity, and the storage class is host path. Okay, and if you have configured this on AWS EBS, you will probably have the EBS host path mentioned up here. Okay, so this is done, and of course we have our deployment. I can show you if I can write deployment correctly. Okay, so as you can see, we are having our deployment running with 1 replica set, and it is currently running. Okay, so this is the PVC. Now let me delete the pod. So let me go to pod, and as you can see we are having this pod up and running, the MongoDB one. So I'm going to delete this, and it is terminating, and you can see it is basically creating again. Okay, and let's go back to our front end, and if I refresh the page, yes, you can see the to do is persisted. Also if you go to MongoDB, and if you refresh it up here, or even you can add some new to dos like the 4th one, and if you refresh, you can see it is getting added, also maintaining the older to dos. Okay, so there you have it. That's how you basically create volumes in containers and how you persist data using volumes. So I hope you like the video. In the next video, we will understand different storage class and PVC volume on cloud services. Okay, as I showed you a little bit how we can create other storage class or block storage to basically persist data if we are running our cluster inside cloud platforms such like AWS. Okay, so we'll do that in the next video. Hope you like the video, and see you in the next tutorial. And till then, keep safe, be happy, and yeah, be healthy.